Everybody, we're looking for a positive integer. Now the natural numbers and the positive integers mean the same thing, so z plus is often a way to represent the positive integers. Now we're looking for the smallest such integer, positive integer, such that this product n+1, n+2, n+3 is a multiple of 299. Now that looks a little daunting, but one way to get a handle on this that really makes the problem relatively easy is just call these three factors x, y, and z. Okay? Now, a very famous result from number theory says that if you have a prime number dividing a product of two things, or three things, or four things, in this case it's three things, this implies that P has to divide X. X is a multiple of P, or this is definitely, not all of them, the or is definitely important here, or P divides Y. Y can be a multiple of P. It has to be, in fact, and under these circumstances. If this is composite, this is not true. Or P divides Z, right? Okay, now, so how are we going to use this to our favor? Well, 299, lucky for us, is the product of two prime numbers, 13 and 23. So we can conclude, based on this truth, that each of these, or one of them at least, is divisible by 13 and 23. Okay? Notice how I just said similarly for 23 to make sure the wording was clear. Now, so we'll go ahead and let A be the factor. And when I said let A be the factors are n+1, n+2, and n+3. So I'll let A be the factor that is divisible by 13. Okay? And we know that that's going to happen. So one of them has to be a factor that is divisible by 13 based on this fact right here. Okay? And we'll let B be the factor that's divisible by 23. And again, this is guaranteed to happen based on this very fundamental result from number theory. Okay? So what we're going to do, and also this very next observation is the hardest one, even though it's easy to note. The absolute value of any two numbers in this list cannot differ by more than 2, right? n+1 and n+3 are the two numbers that are farthest apart, right? So it's this is very convenient at stating something obvious works out very conveniently. So we'll start with A equals 13. We could start with B is equal to 23 and work it that way if you wanted to. But notice an important truth right here is to list the multiples of 23. 23, 46. We're looking for a multiple of 23 as we go through this process. 69. And the fourth multiple is 92, right? Okay. So again, we're looking to see if we can gen multiples of 23 in this list for B, and then we'll have an A and a B that have 13 and 23 as factors. Now notice right here, the way I've labeled things, B, 23 does not divide B on this very first line. Okay. So let's put 23 does not divide any of the B's in this list, right? And we need that. If it happened, we'd be done. We'd be ready to finish the problem, right? And in a similar fashion, if we try for multiples of 26 for the second multiple of 13 for A, we also get an other list where B 23 is. So 23 does not divide B applies to all three lists right here. Now, if you notice, everything, and it's not a surprise, differ in the columns differ by 13, right? 15 plus 13 is 28, 28 plus 13 is 41, 27 plus 13 is 40, and so on, you know? So what we can do here is work our way down to, and this is not hard to see if you, I wrote the whole thing out, but I don't want to bore you guys with the whole thing. If we work our way down to the multiple of 13 equal to 91, okay? It's something you can kind of notice the pattern here, because you'll note right here that 92 has to appear in this list. Here's 92, all right? 69 and 46 didn't happen, and you guys can verify if you want to go through all the drudgery, you know? But it turns out for 91, which is 7 times 13, what do we get right here? We would get 89. 90, And notice I'm skipping the multiple of 3 since it's not, it would happen, but it happens earlier, so I'm just skipping it. Okay, so, and then right here, what do we have? 89. We subtract, let's see here, 190, and then we get 92 as our skip, right? Okay, and you would have 93 to fill out this column. And you see, these are all the integers that are within 2 of 91. 91 would be in the middle of this list, right? It's already a multiple of 13 though, right? So anyway, we can see very quickly here that we need to set, what we want n to be the smallest number. So we would have to start out with, what do we got here? 92. Okay, so we need 91 and 92. So we would want, since we want n to be as small as it can be, we would have to put 91 here, 92 here, and 93 here. You see, and whatever this number is, it's guaranteed to be divisible by 299, since the only two factors of 299 are 13 and 23, right? Well, this is a multiple of 13, all right, and this is a multiple of 23. Again, multiple of 13, multiple of 23, right? So in other words, let me just write that down. This is 7 times 13, and this is what? 4 times 23. And again, those were the numbers whose product is 299. Let me write that to the side. 13 times 23 is 299. Okay, easy to do in your head. It's just 230 plus 69. So that's 299. All right. So you see we got the job done. All we have to do is just set n plus 1 equals to 91, and we get n equals 90. That does the trick, folks. N equals 90 is our solution. Now, I didn't show the entire, if you don't trust what I did, just go back and fill in. I left out a few of the rows. I left out a equals 52, a equals to 69, I guess it would be. 65, I guess. 13 plus this is 52, 65, 78, and 91, right? But you can verify quickly that none of these multiples of 23 appear until you get to right here, okay? This is the first multiple of 23 that appears in this list. I just didn't show all the work to cut down on the length of the video. But in any event, you can bet your bottom dollar that n does equal to 90 right here. Now, just a little bit of context here. We could have just, if it didn't say find the smallest integer, you could have just gone all the way down until the middle number was 23 times 19, right? And that would have gotten the job done. See, we just got to the point where we had 4 times 23, right? But you would have gotten it if you had gone all the way down to 19 times 23, obviously, right? So anyway, that's just the way this one worked out. Actually, I said that wrong. That would be the middle number, okay? The middle number that I'm leaving out here would have, if you let that be 13 times 23, that would also get the job done, but that would not correspond to the smallest n. So n equals 90 is the answer. Thank you for viewing.